Now we did the calcium phosphate molar mass already, right? And it was what, 310, right? All right, so calcium phosphate, it is 310 point what? 174. And by the way, I know you have some quest assignments. Sometimes instead of the word molar mass, they would just say formula weight. Okay, that's the same thing. We're talking about the same thing with different terms. So now, how do we do this? What are we talking about here? First up, we are talking about the number of phosphate ions. It is analogous to what? It is analogous to the fact that, hey, how many people are here? We got two people. So how many fingers are there? Oh, we just look at the ratio. First, you find out the number of people, and then you're like, oh, one person got 10 fingers. And then you do the ratio again. So when we say, oh, how many phosphate right here? We say, well, the phosphate, it's, what is it? There are 2 phosphate ions per compound, right? So we're going to use that ratio in just a moment, but we don't use it now because we are given the mass, not quantity. So here's another thing about ratios, and that is when you multiply ratios, you must make sure that the ratios are, workable with each other. Okay? A good analogy is that if you go to Japan and you have some US dollars, then you would want to know what's the currency rates between Japanese yen and US dollars. It would be kind of pointless to say, oh, yeah, you're going to Japan, let me give you the currency rates between US dollars and euros. You'd be like, thanks, but no thanks. It's useless. So that's why we say, okay, and that's why you think about the if-then statement. If we know the mass, we shall know the number of moles. And by the way, that's 1 mole, right? Is it bigger than 1 mole or less than 1 mole? Less than 1 mole. Is it bigger than 0.1 mole or less than 0.1 mole? Less than, because 0.1 mole would be 31, right? It's less than 31, a little bit less. All right, so we say, hey, I know what I'm doing. I am getting the number of moles of calcium phosphate, and I know it is tedious. And like I said, I'm giving you the minimum notations. All right, all right. Now, there are 2 ways to go from here. Either way, it's fine. Let me go ahead and give you both versions, and I will let you choose. I will let you see both. My first version is this. If I know how many groups of calcium phosphate, then I can tell the number of individual calcium phosphate. It's like, oh, if I know how many groups of people are there, I can tell the number of individuals at the scene. And then I find out how many fingers there are. And that is 1 mole of calcium phosphate to 2 moles of phosphate ions. You can do that. Okay. You can also say, well, if you know the number of groups of calcium phosphate, you may go ahead and find out the number of phosphate ions. No, sorry, my bad. The number of groups of phosphate ions, right? Because every 1 calcium phosphates, there are 2 phosphate ions. So you can go ahead and say, oh, it was 1 to 2. And then that will still be in groups, but we don't want groups, we want the individual. And then you go ahead and find out the number of individual phosphate. All right? The math is the same, but the thought process is slightly different, but they yield the same answer. And like I said, you take care of 1 fraction at a time. Okay, times 2 times 6.022 to the 23rd power. So you shall get 8.93 times 10 to the 22, that many phosphate ions. Does it make sense, we ask? We say, well, what do we say? It was a little bit less than 0.1 mole, right? A little bit less than 0.1 mole. So if you multiply by 2, maybe we're talking about 0.1 something moles, right? So if 1 mole is 6.022 times 10 to 23rd, then 0.1 something would be just an order of 10 less. So that's why 10 to the 22nd power makes sense. That's a whole complete package of this beginning understanding of mole. Do you understand that each mole is a group? And if you do, then we say, oh, cool. Then make sure you know the group concept, it's carried through the entire calculation.